Alright, so now we're going to take a look at a terrible long fraction in quadratics here. Now this is the worst one we have because none of the denominators are like, and so this is a situation where we actually, it would be like if we had 1/3 plus 1/4 plus 1/5. The common denominator would be if I multiplied 3 times 4 times 5. That would be the least common denominator. So I'd actually have to multiply 3 times 4 is 12 times 5 to get my common denominator of 60. So I'd have to multiply each fraction to try to make the denominator be 60 if you were to deal with this in just regular number fractions terms. Well, we could get rid of these fractions if there was an equation by timesing everything by 60. So that's kind of what we're going to do here on this particular problem up top. So we do that by multiplying everything by the product of everything, which would be x times x minus 1 times 12. So this is what each thing gets multiplied by. X times x minus 1 times 12. X times x minus 1 times 12. And what happens is you're left over with whatever doesn't cancel. So on this first one, the x cancels with the x, and you're left with x minus 1 times 12. The second one, the x minus 1 cancels with the x minus 1, and you're left with plus x times 12, which of course is 12x, but I'll change that in a second. And then we have the 12 on the last one cancels, and I'm left with equals 7 times x minus 1. So now you can see, yes, that was a little time consuming, but we've only just begun. Now I've got to simplify everything and make this 12 distribute to get 12x minus 12 plus 12x equals, distribute this to be 7x squared minus 7x. And now I want to make this equal to 0, so I go ahead and I'm going to move everything to the right hand side. First of all, I'm going to combine these to be 24x, and so I'm going to subtract 24x to the other side, and then I'm going to add my 12 here. And again, these 12x's turn into my 24, and I'm subtracting the 24 to move it to the other side. So that's going to turn into 7x squared minus 31x, and then plus 12. Okay? So now this is equal to 0, and I want to see if I can actually factor it. So I go ahead and try the magic x, and I want to multiply the 7 times the 12 and get 84. And then I have negative 31 on the bottom. So I want to see if there's anything that multiplies to be 81 that happens to add to 31. Multiplies to be 84, adds to be negative 31. And it just so happens that 28 and 3 add to be 31. They also multiply to be 84. Well, I need them to add to be a negative 31. So I need to make them both negative. Well, if I multiply them, that'll work to be positive 84. And now they can add to be negative 31. So this one actually is nice. It does factor. But remember, if there's a number in front, I need to divide both of those factors by 7x. So divide this by 7x, and divide the negative 3 by 7x. Okay? And so what's going to happen is, I can reduce the 28 and the 7, because 7 goes into 28 4 times. So then that's going to turn into a negative 4, and on the bottom just an x, so I can write x minus 4. And then the second one can't reduce, so I write 7x minus 3. Okay, so now let's actually rewrite that with some more room. And at this step we should be equal to 0. So all we have to do now is set each one of these equal to 0, and that means that x minus 4 equals 0. So x is going to equal positive 4. And then 7x minus 3 is going to equal to 0, so we're going to get x equals 3 over 7. Okay? So these will be your final two answers that you get. So yes, this is a lengthy problem, but it all works out in the end. You just have to stay with it. And again, each time we want to see if we can solve by factoring. If it didn't here, then we would have had to go ahead and try to solve using the quadratic formula.